Hello, everyone. Clay Daniel with Claiborne LSAT here. I'm going to go way back to the archives to LSAT Prep Test 10, as you know from clicking on this video, that we are going a fair amount back. One of the reasons to do that is that this grouping game has a little bit of an unusual feature in that it has more than 3 groups. You don't see that very often, so it's good to see one like that. So let's just go ahead and note that this is the second game of LSAT Prep Test 10. As always, out of respect for copyright, I'm not going to be reading out the game to you. I'm not going to be putting the text up on the screen. Let's get right to it. I mentioned that there were more than 3 groups. It actually takes a moment to identify what we should even make the group headings here and which ones are the elements or players. There are 6 of one kind and 4 of another, but the first rule speaks more from the point of view of the movies, especially the at least one language in that first rule. That is to say, if you're looking at it from the point of view of an element and it says that element has at least one of something else, that's actually best to be the column header for the grouping game. And then the other rules kind of make it clear that, we're going to want to put the people under the movies and not the other way around. So good way to think about that here. Let's go ahead and make our 4 groups. Typically, obviously, you'd want to write the players, elements down, but for the sake of time, I typically don't do that. Just want to show you the decision tree process, which is why these videos focus only on the setup. The goal is to show you how powerful it is to do as much as you can in advance to write out what we would call advanced game boards. And the questions often they fall like dominoes. They are quite straightforward if you will really, in a disciplined and persistent fashion, walk through the advanced game boards in this sort of decision tree thought process. All right, we know that each group has at least one member. So I'm going to go ahead and put that here on the left. I only draw a space in grouping games if I intend to fill that space. So we're not going to draw the last 2 spaces. We don't know where those 2 kind of extra people go. We have to wait and find out. Now, remember with the decision tree process, if you've watched any of our other videos, that there's nothing we love more than a block. 2 players who are kind of stuck together like that square in Tetris. It's hard to maneuver, unwieldy. That's a good thing because it makes them very restricted. That's H and F in this case. They are always together. And then we even have another block that's L with somebody else. L is blocked with somebody else, but we don't know who it is. Now we also know, looking at star player, H and F, but H doesn't review W. So as we start to think about where that HF block can go, we know it's not on this far right, but theoretically it could be any of these other 3 places. So let's start on the left and move it left to right, as we do with blocks, to just say, what happens if we put HF right here and think about the other rules? Well, we also need G in here. Because that's always the case. And then we need to fill up these other spaces. Well, we only have 3 players left, right? 3 of them are right here. We're going to need 1, 1, and 1 in order to fill our spaces. J is either M or W, so let's definitely use her in W, but then we start to hit a problem. One of the remaining players, L, has to be blocked with somebody else. So we can't separate L and the remaining player K. It doesn't work, we've just discovered, inferred, you might say, to put the HF block in M. And how are you going to infer that unless you actually try it? That's the beauty of the decision tree method and working these game boards out in advance. All right, so let's try again. Whoops, don't need a second space there. Let's move HF over to the right one. Let's say it's under R and see what else we learn. Now it's not as easy to figure out where to go next. Of course, G always goes there. There aren't any conditional rules. So at this point, we have this block of L and somebody else. And grouping games are so often about numbers and the distribution of the players in numbers. If you think about it, we only have 3 left, 3 players. We need to fill the 2 groups, but L has to go with somebody else. So it's going to be a 2 and 1 relationship with what's left. Essentially, L either goes here in S or it goes in W. Let's just try both of those possibilities since we have a nice either or there. L with someone else. Now the remaining players are J and K. We need to fill both of these spaces, but J can only go in M or W. So we're going to have to put J there and K there. Then we'll write the same first 3 again, G, H, and F, but we'll move L over here. J's still going to have to go here because somebody needs to go in S, but it can't be J, so it'll have to be K. It doesn't really matter how consistent you are with writing the spaces. I just make sure to do it when I'm trying to remind myself I need to fill this space. All right, now notice we're done with that branch of the decision tree where we put H and F in group R because either L was there or L was there. There were no other options. So let's go ahead and move H and F over, and we'll find that something relatively similar happens. That is, G is here. We still need L in a block of 2. It's got to be here or here with the other space just having 1. And once again, J is going to need to fill this position one way or the other. It's either LK like this, or we bring L all the way over to the right, let it join J, and K, the floater, fills the last spot. 4 viable options in every game board. We know everything that happens, all 6 players, incredibly powerful. And notice there's an important inference to this game about J. The original rule about J tells us that J could go in either M or W, but look where J always ends up. When we factor in where G has to go and the HF block, there's simply no option for J to ever go in M. That's a major inference for this game, and we discover it not so much by making logical connections in our heads. We stop staring and start scribbling. We get it out on the page, and by writing all those out, we discover the inference. There's very little way that the questions can stump you at this point if you have all this information. Hopefully you've seen the power of the decision tree method in this video, and you'll check out others to see how it applies to different kinds of logic games.